This is Professor Jeff Wilkerson at Luther College with a brief introduction to Exercise 27, Galaxies in the Virgo Cluster from Astronomers as Observers and Experimenters, as published by Kendall Hunt. This exercise shares some similarities with the spectral classification exercise. We're looking at photographs of galaxies, and we're asking, if we look at the photographs of galaxies, can we classify the galaxies that appear in these photographs? So can we look at them and see what classification we can apply? And you could go about this by developing your own classification scheme, or you could go about this sort of anything that has to do with the apparent geometry of these galaxies, how elongated they are, how round they are, what they look like, or you could apply the Hubble tuning fork classification scheme if you prefer to do that, and to think about what you're learning from the distribution of galaxies here. So this is a lot about identifying these galaxies and then looking at the types of galaxies as they appear. As such, if I use this exercise, it's really, when we think about the process of science that we've developed early on in this textbook, this is a lot about observing and careful measurements. So taking careful measurements, so planned observing is what we're looking at here, and trying to understand what we can learn by very carefully going through the images here and making a model, counting up the types of galaxies that are in there. And then we have a spectrum of one of the galaxies in this cluster. By the way, when you're doing this, there is a note in this activity that suggests that this might be easier to done with a magnifier to help identify what stars and what are not stars. I think that's absolutely true. So I think if you have a jeweler's loupe or something that helps you really work slowly and carefully, grid this thing off and work slowly and carefully along these images, that's going to really help you get something out of this exercise. And then you can measure the distance. You can apply the Hubble-Lemaitre law by measuring getting the distance from the Hubble-Lemaitre law by measuring the redshift of these galaxies. So you've got a comparison spectrum right there, and you've got this line right there. Go look at the Hubble-Lemaitre law. I think that was exercise 14. Nope, it's not exercise 14, it's 12. Exercise 12 is the Hubble-Lemaitre law and how we use that to find distances to galaxies and galaxy clusters. And we looked at the Virgo cluster in that exercise. So you can go back and look at that exercise and think about how you would do that with this exercise. Maybe think about doing portions of these two exercises together if you like. So that's really what we're doing. We can think about trying this as a project. We hint at this at various places in this exercise to say, what if you wanted to know how galaxies evolve over time? How would you go about making that measurement? What would you look for, and what kind of biases would be built into your observations? To say, if you're looking at you're looking at young galaxy clusters, younger galaxy clusters, so you're looking back in time, you're looking a long distance away. Some galaxies are easier to see than other galaxies. What kind of bias does that impart to the work that you're doing? So there's an opportunity here to think about how to do this kind of work in more of a project setting. And you could go get all kinds of data. You could go to the Galaxy Zoo site and look at the work that they're doing there, and you could go get Sloan Digital Sky Survey plates and see what you can get from that information. So you could actually turn this into a bigger project and think about doing other stuff along those lines. But this is a good entry into it, to think about observing and the kinds of careful observations you need to make in order to get what you need to do to make models and to do that other kind of work. Good luck with it. Let me know if you have any questions.